Hello guys, welcome to Stats with Warnke. I'm excited to take on the challenge of AP Stats with you today. Today we'll be covering translating descriptive statistics. Here is our learning target for today. We're going to be able to describe the effect of adding, subtracting, multiplying, or dividing a constant on the shape, center, and spread of a distribution of data. So what that really gets at is just that normal transformation. So if you have a function, in this case a distribution of data, what happens to it, the shape, center, and spread, as you add, as you multiply, as things change. So a transformation, just a quick definition, is what you convert from original units to another scale. So a lot of times we'll take something from, for example, Fahrenheit into Celsius, or we'll take something from feet into meters, or vice versa. As you can see on the slides here, we're going to talk first about the concept of adding and subtracting a constant. So if we have a distribution and we add some number a to each of our elements, or subtract some number a to each of our observations, what is that going to do? So the first thing is that's going to mess with our measures of center and location. So for example, our median or a median is going to move in the direction of that addition or subtraction. So too our quartiles. So Q1, Q3 will move in that same direction. Same thing applies to our percentiles. What won't change is the shape of the distribution, and also our spread will remain unchanged. So quick way to look at that is either our range or IQR. Standard deviation is obviously something we kind of need a little bit of technology help for to do it quickly, but in order to do range, that's just a quick subtraction problem. So here's an example. We have these points, this set of points. So imagine this is some like homework learning check, some quick assessment. It's out of 2 points. So you can either get a 0, a 1, or a 2. So we had a couple people get 1s, a few people get 0s and 2s. Let's say the teacher decided to add 7 points. So everybody gets a 7-point bump. Instead of getting that 50%, that 1 out of 2, here we get 8 out of 9. So teacher decides that 8 out of 9, that's pretty good. Everyone just gets shifted over by 7 points. That mean our median went from being 1 to being 8. Our mean went from being 1 to being 8. Our range was 2. So 2 minus 0, it's still 2. 9 minus 7 gives us our range value of 2. So that center moved by that constant value. So we added 7, so our center moved up by 7. Our range stayed the exact same. That measure of spread stayed the exact same, and so too did the shape of our distribution. It still maintains that approximately symmetric shape, or in this case, it is symmetric. The other thing we can do is we can add, or besides adding, is we can multiply or divide by a given constant. So if we divide by some number, in this case we'll call it b, then things change with, again, our descriptive statistics. Our measures of center and location get multiplied by that value. So if we are going to multiply by a number, we take our median and we multiply by that number. We take our quartiles, we multiply by that number. We take our percentiles, we multiply by that number. Same thing applies to our spread. If we have our range or IQR, we multiply by that number, which is different than what happened when we added by a constant. What doesn't change is the shape. Although there is one thing. When we multiply by a negative, it does reflect our shape. So if it's approximately symmetric, that's not going to change things. But if we have something that is skewed right, that'll switch to being skewed left, and vice versa. So as we did with our guesses for the room width, it's going to reflect things around 0. So here's a quick example of multiplying by a constant. We have, again, that same homework learning check quiz, just a couple points. If the teacher decides to multiply by 50 and make it out of 100, that 50 is still 50%, so 50 out of 100, same as that 1 out of 2. But it's the spread that increases. Going to that original problem, we had a range of 2. Now we have a range of 100. So that 2 gets multiplied by that 50. And that applies to any of our descriptive statistic principles. So this is the example in the notes. Here is a graph and table for a specific test. So we want to say the maximum possible score on this test was 50. Looking at these, the teacher decides to add 5 points. So you can go ahead and pause the video here and try this on your own, see what you end up with. How would this change the shape, center, and spread of the distribution? Well, using our principles we just talked about, it would look like this. So our score plus 5, that's going to increase our mean by 5. It's going to increase our median by 5. Our quartiles each move up by 5. But our range and our IQR, you can see those on the end of the table here, those stay the same, because when we do 46 minus 37, we get the same thing as when we did 41 minus 32. So all the measures of center increase by 5, but the shape, as you can see from the graphs, is the exact same. We still have that skew. Look at the tail. So we have that skew going to the left. Instead of adding 5, let's say the teacher decides instead to multiply each by 2 to make it out of 100. What does that do to our shape, our center, and our spread? Again, take a moment, pause it, think about it, and then write down your answer. It should look something like this. From taking a look at the graphs, we can see that, again, that shape stays the same. It's still skewed to the left. But those spaces in between each of our points, kind of on that left-hand side, got twice as big. By multiplying by 2, doubled that size. So the measures of center and location and spread all have doubled, just like the individual observations. But the shape has not changed. It still has that left skew. Here is that next problem for our taxi cab. We have somebody who has ridden in a business taxi, and so what they want to do is record all of that information about how far they went and all that type of information. What we know is what they paid. So we had a mean fare of $15.45, so $15.45, and a standard deviation of $10.20. So the problem in your notes says, what are the mean and standard deviation of the lengths of his cab rides in miles? So using that equation, we can figure out what will happen to our mean and our standard deviation. Our mean is our measure of center, standard deviation is our measure of spread. So take a moment to pause the video here and then continue when you have your guess. So we need to remember that mean number and our standard deviation number. Our mean number of 15.45. Rearranging that equation, we can then subtract $2.50. So if we take that $15 and subtract $2.50, we get that $12.95. And then we can divide by 2 to get the number of miles, and we get 6.475 miles. To find the standard deviation, we can do that same process, but instead we're only going to divide by 2. So remember that when we add or subtract a constant, that doesn't impact our measure of spread, only when we multiply. So in this case, we are dividing by 2, so we can divide that number and we get that 5.10 miles. Thanks for joining me today. See me in class if you have any questions. Thank you for taking on the challenge of AP Stats with me today.